Okay, so when we are simplifying radical expressions, we're always looking for, when we have just constants like the square root of 180, looking for the largest square that goes into 180. Okay. So what's the largest square that goes into that?
36.
36? Okay. Remember, the best way to check it is if you have your calculator, we can do 180 divided by x, and then we go to our table, and start looking until we have, oops, I had changed something. All right. And look at all of our combinations we get here. So let's see, 4 goes into it 45 times, but 5 goes into it 36 times. So 36 is a square, so I'm going to change 180 will be the square root of 36 times 5, which is the square root of 36 times the square root of 5, and the square root of 36 is 6. So you've got to, even if you can do this with a basic calculator, okay? Even if all I have is a scientific calculator. If you're using one of these at home, okay, just a regular calculator. We know what the squares are, right? You have them written down. So what I could do is I could take and just start going 180 divided by 4. That's the first square. All right? Okay, it works, 45. Okay? But is that the biggest one? Okay? So you would need to check to see what's the biggest one. So I do 180 divided by 9. Okay? Oh, that works too. Okay? So I know what that is. Do 180 divided by, let's see, 16 is the next one. Okay, that's not one. 180 divided by 25. Okay, nope. 180 divided by 36. Okay. And the thing is that you're looking for, as you're getting bigger, the numbers are getting smaller so that you can't use them anymore. Okay. But you need to check them. And you can do it with a scientific calculator also. But we're writing them. The product of a square and a prime number. Okay, everybody knows what prime numbers are, right? So you could also just look at the prime numbers, okay, and see what happens. Okay, number 7, square root of 648. All right, we're going to have to check this one. This is going to take a little bit more work. 648 divided by x. Go to my table. Let's see. 4 goes into it 162 times. 8 goes into it 81 times. Now that's okay, all right, except for, does the 8 have a square that goes into it?
Yeah.
4 goes into 8, right? Okay, so there is a square, another one. So this isn't the biggest one then, because 8 has a square that goes into it. 4 goes into it. Okay? So we're going to have to keep going down. Keep going. Let's see. 36 is a square, all right, but we got 18 here. That's a bigger number. There's got to be another one. Or did I miss it already? Hold on, let me go back up. I must have missed it. Operate. Click. Except it froze. Okay? Mine went too fast. All right, so what do you get? All right, so I knew I had 8 and 81, so it's got to be a smaller number than that, and I guess I missed it. It's at 2, right? 2 and what? 324. All right, except we didn't know that 324 was a square, did we? Okay. So let's say you don't. So let's go back here to this, I know 81 and 8. Let's use that for just a second. Okay. Now, 8 can be broken up into a square, right? Okay. We said 4 goes into 8. So I could write this as the square root of 81, square root of 4, square root of 2. Square root of 81 is 9. Square root of 4 is 2. Okay, so I'm going to multiply them. 9 times 2 is 18. So you can do that. You just have to, it just takes a little bit more work then. Okay, sometimes you might have to do it more than once because you can't see it. Right? But you can't use numbers that are not squares. Like in number 5 here, I can't use 18 and 10. Right? Multiply them, I get 180, but neither one of them is a square. Okay? So you got to find the squares. All right. Let's look at these ones with fractions. Okay. The quotient rule says I can rewrite this as the square root of b over the square root of c squared. Is there a square root of b? No. What about the square root of c squared? C. So this is the square root of b over c. Make sure when you make your fraction bar that you make your fraction bar all the way across. Okay? So that you're not accidentally doing this. It's not the square root of b over c, it's the square root of b over c. Now, the one thing I told you yesterday is always simplify first if you can. Here we go, number 15. Does 4 go into 36? 9 times, right? Okay, so I can simplify, so I have 1 over 9. How about the x's? Can I simplify one of the x's? Okay, we have 2 in the numerator, 1 in the denominator, so I can cancel 1 there. So I have an x in the numerator. Okay, so now I'll change it, use the quotient rule. Pull them apart, the 2 separate radicals then. Is there a square root of x? No, because it's to the first power. Okay. Is there a square root of 9? Okay, so we get the square root of x over 3. So the biggest thing is simplify the fraction first. Okay? If you do that, you're good to go. Right. A to the 4th over a cubed, so we have 7a over 9. When I simplify it first. Okay, I can cross out 3 a's. Square root of 7a, square root of 9. Can't simplify the numerator, but the denominator equals 3. Okay. All right, so we worked on some fraction ones. We're going to work on some other ones. Okay, they're a little bit harder. The ones we just did simplified so that the denominator was really easy, right? Square root of whatever, wrote it down there. Okay. Now we're going to look at some where we actually have to simplify the numerator too. Okay. So we're going to start out with, we have a square root of 108 over 25. What's the first thing I look to do? Okay, simplify. All right, does 25 go into 108? No, it goes into 100, right? Okay, but not into 108. So I'm going to use the quotient property then and write it as the square root of 108 over the square root of 25. Well, we know what the square root of 25 is, right? Yeah, that's 5. So I can make my new denominator 5. Okay. Square root of 108. Okay, that's not a perfect square, is it? Okay. What's the largest perfect square that goes into 108? Okay, if I'm not sure, go to my calculator. Still not working. All right, go to my calculator. Here we go. 108 divided by 2 is 54. Is 54 a square? Okay. 108 divided by 3. 36. Hey, that's a square, isn't it? Okay. So I can make this the square root of 36 times 3. So in the numerator, I can use the product property. Square root of 36, square root of 3, all over 5. And then the square root of 36 is 6. And then you can put the square root of 3 in the numerator, or you can put it in the middle of the fraction bar. Either way, does not matter. Totally up to you. But you're looking, okay, what is not a perfect square? Find the largest perfect square that goes into that number, okay, and simplify it. All right, here we have a little caution over here. Throwing out the caution flag. It says in the expression 4 square roots of 5 over 5. All right. Big thing is that fraction bar goes under the whole thing. Okay? It's not this. Okay? It's not that. Okay? You can't simplify the two 5s. All right? So that would be completely simplified as 4 square roots of 5 over 5. That's a no-no. Okay? Don't do that. Some of you will want to. Okay, square root of 9x cubed over 16. First thing, look to see if we can simplify it. All right, does 9 go into 16? No. All right, so I can't. So I'm going to use the quotient property to write them as two separate radicals. Now, in the numerator, I have two different things, right? I have a number and a variable. Okay. So we said we're going to pull them apart. And this is x squared times x, right? Okay. If we have an odd degree exponent, we write it as the even degree, one less, and then x. And some of you are probably getting to the point where once you go here, you're good, right? Okay, how many of you can stop there and write your answer? Okay, hopefully quite a few of us can, all right? If you can, then that's fine. You don't have to write out the next step if you don't want to. Okay, so next step, let's see. I know that square root of 9 is 3, and then I can write this as two separate pieces. And square root of 16 is 4. All right. If you can get to the answer from here, I'm good with that. Or you say it this way. All right. You can go either one of those steps. Okay? All right. As far as the square root of x squared times x. Okay? If you want to go from here to step 3, that's fine. And bypass step 2. If you need both of them, use both of them. Okay? Whatever you need to do. So we get 3x square root of x over 4 is our answer. Square root of x squared is x. So you have to take your time with them. And you're always looking for largest square that goes into them. Largest perfect square that goes into them. All right, so last thing then. Hey, we have a story problem. Okay. A quadrangle on a college campus is a square with sides of 250 feet. If a student takes a shortcut by walking diagonally across the quadrangle, how far does he walk? So give the answer as a radical expression in simplest form, then estimate the length to the nearest tenth of a foot. So what's the first thing I should do in this case? What? Write down 250? Are you sure? Okay, it's a good idea. Write down 250. But this is talking about what kind of an object? A square. So the first thing I want to do is draw a square. Okay. It says the sides are 250 feet. All right, so 250, 250. And it says that this person's going to walk the diagonal. So I need a diagonal here. So I need to draw the diagonal in my square. So they want us to find the length of the diagonal. What's another name for the diagonal here? Nope, not the height. It's another name for that diagonal. What do we have here? Okay, I just made a right triangle, correct? And how do you find the hypotenuse of a right triangle, Angela? Oh. Okay, the line is the hypotenuse. Good. Okay. All right. Pythagorean theorem. A squared plus B squared equals C squared. Okay. Pythagorean theorem. What's the value of A? What's the value of B? All right, so these are both 250, and I'm going to tell you a secret, okay? All right, this is a very important secret, okay? It's really not a secret, but, okay? If you're finding the diagonal of a square, okay, and actually you should know this if you had geometry, okay? The diagonal of a square is S times the square root of 2. And S represents the side length. Okay? All right. And I'm going to tell you why right now, and I'm going to prove it to you with just this problem right here. Okay? I have this, right? If I have something plus itself, I have two of them, don't I? Okay? So that equals C squared. And how do I find C if I know C squared? Okay, take the square root. All right. So I have the square root of 250 squared and the square root of 2, don't I? Okay. And what's the square root of something that's squared? Okay, it's that thing, right? Because the square root of x squared is x. So this answer here then is the diagonal is equal to 250 times the square root of 2. All right, so anytime you're looking for the diagonal of a square, it's the side length times the square root of 2. And then they want us to find that number to the nearest tenth of a foot. So I take my calculator, which is now working, hopefully, and I'll do 250 times the square root of 2. So this is 353.6 feet. .353, excuse me. But the diagonal, okay, a squared plus b squared equals c squared, the Pythagorean theorem.